Okay, so I got to restart. So we're going to, on this problem here, we're going to grab all the data at the bottom. These are large firms, medium firms, small firms, and it's the number of days it took the firm to pay. So this large firm took 17.15 days to pay. This firm took 16.4 days to pay. This this medium-sized firm took 16.7 days to pay. This small firm took 10.35 days to pay. We want to know if this average equals this average equals this average. So we're going to highlight and copy this data into Excel, which I've done, right? We got to fill out the table. So highlight everything from large all the way down to the last number, minus 13.56. Highlight that data. Keep it highlighted. Right? Keep it highlighted. Now what you want to do is click on the data tab. Everybody click on the data tab. Right there, data tab. Did everybody click on that? Emmanuel, did you click on it? The data tab? You have these highlighted down here, right?
Yeah.
Then you click on the data tab, and then over here you should have data analysis on the right.
Yeah.
Does everybody have data analysis on the right? Julia, over here on the right. Sweet, over here. Do you see it? You might have to make your window wider to see it. Make your window wider to see it. So on the data tab of the ribbon, right, Julia, right here, click the data tab. And you see data analysis over here?
I don't see it.
You don't see it? Okay, what you have to do then is you have to add it. You have to do an Excel add-in. So everybody click File. Everybody click File. Then click More. Did you click More? Options. Click Options. Do you guys get the screen? You get the screen, Emmanuel?
Fine, but I don't see more.
You got this one right here? Here, I'll do it again. So under File, click down here, Options, under File. You might have to maximize the screen. Did you click Options?
Yeah.
And you should get this Excel options, right? Now you want to do is go to Add-ins. Down here at the bottom, Add-ins on the left, Add-ins. You got Trust Center and Add-ins, right? Is Manage, is that drop-down menu Excel Add-ins?
Yeah.
Julia, Add-ins right here. Hit Go. And then you should get this here, right? Does everybody have Analysis Tool Pack check marked? You have it check marked?
No.
Check mark it. And then hit OK. Now on the Data tab, you should see Data Analysis. You got it? Okay, now click Data. Now you still got the data highlighted, right? Labels and numbers. Click Data Analysis. And do a ANOVA single factor. You have to scroll to the top. ANOVA single factor. Not ANOVA two-factor with replication, not ANOVA two-factor without replication, ANOVA single factor. Okay.
Single button.
Yeah. ANOVA stands for analysis, AN analysis, O of VA variance. That's what now ANOVA stands for, analysis of variance. Click OK. Oh, that's okay. All right. So what we're going to do here is you have to input the range. So over here, click the white box right here. So it's blinking in this box, input range, right? Is it blinking right there? Click large, hold down your left button, and then drag it all the way to the bottom. So that all the labels and numbers are highlighted. You got it? If you don't do it right, you have to redo it. right? As long as you do this, as long as you get everything highlighted from A1 down to your last cell, C, in my case, C45, you'll be golden, right? You want to make sure, why do you want to make sure columns are check marked? The data are in columns, right? They're organized by columns, right? Why do you want to click on labels? The first row includes labels, right? Right. And then let's go back and find our significance level. My significance level is 10%. What's your significance level, Julia? What's yours, Emmanuel?
10%.
Okay, we're going to put in 10% then, all right? So right here for alpha, you want to change that to 0.10. Yep, already got that? And now click on output range. Everybody clicked output range? Click in that white box to the right of it. So it's blinking in there. Huh? It's gone? Okay, good. All right. Now you want to just click on like E1. So I'm going to put the output next to the data, right? We're almost done. All we got to do is now is hit OK. So down here in output range, you should have E1. And then OK. Boom. Right? Boom. Put all the numbers in 4 decimals. All the numbers in 4 decimals. Add them in 4 decimals, right? That's my ANOVA table. What does it do? It gives me averages. It gives me variances. Right? It gives me averages and variances, right? Does one company, one type of company have a larger average? Which company has the largest average? Mine's medium companies. Yours is small? My largest average is from medium companies. They take the longest to pay on average. Right? Okay, so all we gotta do is fill in the information, right? The mean time to pay for large companies is what? Minus 17.6511. Mean time for medium companies to pay is mine is 18.5668. Mean time for small companies to pay, mine is 18.1425. I'm getting those numbers from here. See that? See that? I'm getting the numbers from here.
Okay.
I'll make the numbers red. You see that? I'm getting the numbers from there.
Okay.
Large, medium, small. What about the variances? Well, I'm going to get them to the next column and column I, right? 18.478. Whoop. 18.8478. 17.1521. And then 34.8395. Notice about the variances. Are the variances, they look similar? Are the variances, are my variances the same? These two look pretty close, right? Close can be equal in statistical sense. Look at this one over here. Some small companies might be more at risk of closing, right? So some companies that are small might take forever to pay, whereas some companies that are small might pay immediately, right? That's why that variance is so small. Okay. The count is 44 on each, right? In my case, 44. I get those from here, right? Everybody see that? Now let's just see if we got it right. Hit enter. Everybody get green check marks. You get your green check marks, Emmanuel?
Yeah.
You got it? Okay, now the first assumption of ANOVA is the variances are equal, right? Which is the biggest variance? Which is the biggest variance?
You want the 34?
You want to divide your biggest variance by your smallest variance. Those are my biggest and smallest variances, right? We're going to test this assumption. The variances are all equal, right? Over here, I took my big variance and I divided by my small variance. You see that? Divide your big variance by your small variance. Is class over? Okay, all right. What we'll do is I'll keep recording this, then I'll post it on the LMS. Is that cool? You want to stay?
Yeah.
Okay, cool. All right. So you got what, Emmanuel? I got 2.031.
8 point.
You have 8?
No, 1 point.
Oh, 1 point. Okay. Make it 4 decimals and copy it into here. But have a good weekend. You have the right number on the F statistic? Oh, I'm talking to Emmanuel. Yeah. Have a good weekend, Julia. You had the right number on the F statistic?
Yeah,
Okay. So then what we're going to do over here is we're going to do the F distribution. F dist dot RT. Do the F distribution. So you type equal F dot dist dot RT.
Yeah.
Got it? And then parentheses. Click that F statistic you just calculated. Right? And then comma, and then you want to type in 43, comma 43. That's, sorry. You want to type in your degrees of freedom.
Oh, okay.
43 and 43. My degrees of freedom are 43 and 43, right?
Yeah.
Okay.
It's 40.
Emmanuel? So the degrees of freedom just come from this table over here in the my open math problem, right? 43 and 43. Mine are, what are your degrees of freedom?
40.
40? Okay. So you got equal F dot dist dot RT J7 or whatever your F statistics in, right?
Yeah.
Comma 43, comma 43.
Yeah.
I got 0.01.
Okay.
Oh, it's not working, right, for p-value? It's a two-tailed test. 2. Multiply that whole thing by 2. And then plug that in. There it goes. You just multiply by 2. Value small. Because the p-value is smaller than significance level, that means this is bigger than the critical value. When that happens, we have evidence that this is not true. The differences are big. So the bigger the F statistic, if the F statistic is considered big, then the difference between those variances is big. So we would say the variance is rejected. Let's just keep it as rejected. And I'll fix the algorithm later. So your p-value is smaller than your significance level, right? That means you have a big F statistic, which means the differences in the variances are big, right? Now here, the skew, are the skews all pretty close to 0? Are the kurtosis values close to 0? These 6 numbers should be close to 0. This chi-square stat is, these are all very big chi-square stats. Actually, they're not very big chi-square stats. The p-values are small. So the difference between what we observe and normal distribution, those differences are small. So it looks like it takes a large customer, it takes large customers to pay is normally distributed. We're not going to reject that because the p-values are small. when the p-value, when the p-values are big, these test statistics are small, and small test statistics imply that the difference between the data and normal distribution is small. So these should all be not rejected. There you go. It's good. I just had to fix that variances are equal 1. And our final one, our F statistic is what? Emmanuel, you get the F statistic from right here? See that? That F value next to MS, this is your F statistic. You want to copy that and paste it right here. You want to grab this P value here too, see? Grab that P value and paste it right here. So you got the critical value determines whether the F statistic is small or big, right? So you're going to copy this number here and that number there to here, and you should get the correct answers. Okay. So what do we conclude here? One of the problems we have is we don't know if this ANOVA is giving us the right answer because this assumption, we rejected this assumption, right? So down here, we're kind of unsure. If we didn't test for this right here, if we didn't test for this at all, and we just looked at the ANOVA, and we just look at these results, we see our F statistic is small, it's not big. So when the F statistic is small, that means these differences in the mean are small. See, if this was like 5, one of these would be really big, right? But because these are all really close to each other, our F statistic is small. So if all we did was the ANOVA, then what are we going to do? We're going to conclude the average times it takes large, medium, and small firms to pay are equal. We're gonna not reject that. We're going to accept it. We can't say accept. We're going to not reject it.